Hi, my name is Brian, and I am here today with Miss Wynn, and we are going to talk to you about some science topics. One of my favorite topics in science is energy. I like talking about energy because it's a confusing topic, and one of the things that's confusing to me is that energy is not a real thing. So you might think, well, I've heard of energy before. I've heard of things like solar energy. How is it not a real thing? And so let me explain that. And to help me explain that, I'm going to share with you just the cover of one of my boys' favorite books. This book is called What to Do with an Idea. And the reason I'm sharing this book with you today is because an idea is a lot like energy. In this book, and you can tell just from the artist's artwork, that this is how the artist draws an idea. A set of chicken legs, an egg, and a crown on top. Now, that's not a real thing. There's no animal that has an eggshell all the time and a crown on top and chicken legs. So the reason that the author came up with this idea or this way to draw an idea is because ideas are not a real thing. Ideas are just something that live in our minds. Now, the same thing is true about energy. There's not a real thing out there called energy. We can't go out somewhere and hold something and say, this is energy. So, what we know about energy is that things change when energy changes. Or maybe it's the other way around. Maybe it's that energy changes when things change. Either way, what we want to realize is that change and energy go hand in hand. So we're going to start this off with a scavenger hunt. And what we're looking for is things that change. So I have some examples here. Some of these examples are on your sheet. The first one is a light bulb. So this activity page 1.1 says that a light bulb, and I use the flashlight because it has a light bulb in it, a light bulb can change from not bright to bright again. That's a change. Now, another thing that can change is an electric fan. An electric fan changes from not moving to moving. And so that's another change. And it can even change more, changes to faster and even faster. And then it can change again so that it's not moving. So those are two things that change. And here's another thing that changes. Grass changes. Now, this isn't actually a grass. It looks like one. This is called sedge, and I know that sedge changes because if you ever get it in a garden, you will see how fast it grows. Sedge changes quickly. It gets much taller. Now, take a couple minutes and look around for some things that you can think of that change around your house. After you pause and come back, I'll share with you a couple other things that I saw that change. Are you looking? All right, welcome back. So other things that change. I kind of made a list here. I said another thing that changes is a glue gun. A glue gun gets hot, the metal end of it gets hot, and when it gets hot, it has glue inside of it, and the glue inside of it melts. So that was something that I saw that changes. Another thing I saw that changes is a hole punch. Now, a hole punch is a little bit different because part of the way that a hole punch changes is that I have to actually make it change. So I have to squeeze it together, but then it can change on its own after that. Once I squeeze it together, it can pop back open on its own. So I said that a hole punch changes. The last thing that I said is something that's pretty special to me, and that is this hand drill. And I said that it changes because it changes from something that spins in one direction, that's my hand spinning up and down, to something that spins in another direction, and that's the bottom of this drill spinning. So those are things that I saw change. So before we get started talking about energy, we're really going to focus on things that change. Because again, what we know is that when something changes, energy changes. And we'll worry later on about whether energy is causing the thing to change or whether the thing is changing and that causes the energy to change. All right, Miss Fong has a reading that she's going to share with us about energy. And after that, I'll be back and we can talk a little bit more about some things that change.
Welcome, fourth graders. Hope you enjoyed the scavenger hunt that Mr. Kane had led you in previous to my introduction. My name is Miss Flynn, and I will be Mr. Kane's co-teacher for this unit in science. I have been teaching in elementary schools for about 20 years, involved in them for some 20 years. I live in Nashville right now, but before that, I lived in California for many, many years. So you probably noticed I have a California accent, which is very different than your Tennessee accents that I've had to get used to since I've moved here a couple of years ago. I have 4 children, two who are grown up right now. They are just one son and one daughter, and I have 2 boys living at home with us. They are 12 and 14. We also have 2 dogs that we take care of and play with, and sometimes have to, discipline them for being a little loud. But right now they're being really quiet, so it'll be really good for us as we continue our learning today. All right, so this unit is all about energy transfer and transformation. So this is the actual book that we'll be reading, and you will have a copy of this available if your teacher or your trusted adult is able to print them out for you. So this is the cover of our book that we'll be reading, which has lots of different images, including some people and something called a pendulum clock. So it'll be really exciting for us to learn. The big question that we're going to study during this time is really thinking about where we can see evidence of energy causing change or energy getting change. So when you look at this title, when I look at it, I see transfer and transformation, which both have the prefix trans, which I know means like going across, kind of like in transportation. I also see the root word form, which I know means shape. So that tells me that in this unit, we'll be learning about where energy goes or how it travels or moves about, and then also how energy can change its form or its shape or its the type of energy that it is. So let's move on. Our objectives today are to give examples of energy causing some change. So that's my goal and your goal for learning today. Okay, so here's the table of contents for the book that we're reading. You can see here that there are 7 chapters. And when I read over them, I can see that there are a lot of different things about energy I'll be learning about. I'll even learn about energy and speed, how they're related, about collisions, how energy even solves problems. And I guess we'll even learn a little bit about Thomas A. Edison, whom I know is a pretty famous inventor. And I think he had something to do with the light bulb. You might have heard of that as well. All right, so here's our first chapter. We're just going to read one chapter today, and it's called Energy Causes Change. Right, so again, the question we want to think about is where can we observe evidence of energy causing change or leading to change, I guess. You walk into a dark room, you flip a switch. What changes? The room changes from dark to light. You are holding a balloon in a quiet place. You stick a pin into the balloon. What changes? The silence in the room changes, and you hear a loud sound. Pop! A toy car is sitting on top of a table. You give the car a push. What changes? The toy car changes from sitting still to moving. So here we have some examples of some of the events that happen that involve energy, and things are changing, right? So, but I don't really understand yet what this has to do with energy causing any changes, because that seems a little bit confusing to me. So I'm going to keep reading, and hopefully we'll figure this out. If not in this chapter, hopefully by the rest of the readings and even more demonstrations from Mr. King. So whenever there's a change, there is some form of energy causing the change. Energy is the ability to cause change. Energy exists in many forms. It causes different types of changes. Okay, so I've underlined this part because this is pretty important, that energy exists in many different forms. I'm not really sure what forms yet, but remember the title of the book was about transformation, so now it has confirmed for me that we are changing some forms in energy. And again, it causes different types of changes, at least that's what it's saying. Kind of like here, where there's a water balloon, when you pop it, and obviously the water falls out and you have a big noise, right? So I'm going to keep reading because I still don't understand how that works. All right. Change is evidence of energy. When you see changes in the world around you, you are seeing evidence or proof of energy. Look at this picture. What changes do you think are happening? When I look at this picture, and I think that, I'm hearing the waves crashing, onto the rock over there. So kind of like the roaring sound. So it's not really quiet at the beach here. I think there's wind moving, so the air is kind of changing because I can see that there are waves happening here. They're moving here. And because I've been at the beach lots when I lived in California, and I know when the water moves in, you can see the sand moving too. And so that's another change that's probably happening. And the caption for this picture says, all of the changes that happen on this seashore are the result of energy. Okay. I'll keep reading. As the wave crashes onto the shore, the water moves. That is one change. Imagine you are there on the seashore. You hear the sound of the water splashing against sand and rocks. The sound changes because of the movement of the water in the wind. Another change is the movement of the sand as it is pushed by the water. And there's a change happening that you can't see. The temperature of the sand is changing as it is warmed by the bright sunlight or cooled by the water. All these changes are caused by some form of energy. Now, I didn't really think about it before they said it here, but it is true that things do change even if you don't see it. Because I've been to the beach and it definitely changes. Like the sand in some places is hot, and in some places it's cooler. Like with the water, if it's cooler, or if it's under the shade, it's cooler. But definitely there are times when the sand's so hot you have to have shoes on, otherwise your feet feel like they're really burning up. Right, so lots of thinking happening here. All right, so this next page, it says energy occurs in different forms. So this is the part where we're going to learn about some of those transformations, maybe, or at least the different forms. It doesn't say it's changing forms, it's just about the different forms. So, energy exists in many forms. For example, think of a carousel, a merry-go-round that you might see at a carnival or amusement park. Now, here's the carousel. Hopefully you've been on one of these, or maybe you've seen it on video somewhere. Motion. The carousel spins around. The horses move, riders up and down. All these moving objects have energy of motion. Sound. As the carousel spins, let me stop there before I move on. Okay, so that first section is about motion, so I want to make sure that motion is one form of energy. Okay, the next paragraph is sound. As the carousel spins around, it plays loud, cheerful music. The riders laugh and shout to friends. The carousel and the riders are producing sound, another form of energy. So motion and sound are both kinds of energy, or different forms of energy. And so this caption here says, you can observe evidence of many forms of energy in a spinning carousel. Well, so far we have two. Let's see what else there is. Lights. The bright lights on the carousel light up the ride. The bulbs give off the form of energy called light. Oh, yes, light's energy too, huh? Heat. If you're riding a carousel, don't touch the bright light bulbs. Why? Because they are hot. The bright bulbs not only produce light, but they also give off heat, another form of energy. Okay, so now we have light and heat. And I know not to touch the bulb because whenever our light bulbs go off, or like when they burn out, they're still hot. So I have to wait a while before I change it. Electrical energy. The carousel, its musical speakers, and its shining lights are all powered by another form of energy. If you look closely around the ride, you will find electrical cords connecting the carousel to the source of electrical energy. Okay, so we have 5, I think. There's motion, there's sound, light, heat, and electrical energy. So those are all different forms of energy. And these are things I can find in my house too, especially electrical energy, right? All those devices that we have plugged in, like this computer. All right, so this section is called Objects Can Store Energy. Whoa. I'm going to read about this. When you see the waves crashing on a beach or watch a spinning carousel, you can see changes happening. The changes are evidence of energy. But energy can also be present even when you don't see such evidence. That sounds kind of interesting. How can you see the energy? How do you know that the energy is there if you don't see it? When a rubber band is not stretched, it isn't causing any change. There's no evidence of energy. Right. But when the rubber band is stretched, it now has the ability to cause changes if it is released or let go. Okay, so if I'm stretching, I don't have a rubber band with me, but if I have a rubber band, if I stretch it, then it has energy? The stretched rubber band has stored energy. When the rubber band is released, it moves and makes a sound. Those changes are evidence that energy was stored in the stretched rubber band. So the stretched rubber band has energy. It's true when we release it, like when my kids were little, they liked shooting with rubber bands when we were at my classroom setting up. It wasn't kind of hurt, but it did make a sound, and it definitely hurt because it moved really, really fast. So I guess that's evidence of energy. Otherwise, it wouldn't hurt me, right? All right. Inside a battery are chemicals that store energy. When you put a battery in a flashlight or a toy, the stored chemical energy will be released and cause a change. The energy can make the flashlight light up or the toy move. Okay, so let me see the key ideas here. There's a battery. So inside a battery, there are chemicals that store energy. Oh, so that's what's inside batteries. And then let's see what else. So then we have the chemicals. So the stored chemical energy gets released, and that causes a change. Oh, yeah, because when you put the battery in, like in the flashlight, then I turn it on, then that makes the battery energy go to the light and make it turn on. Is that what it's saying? Oh, look, I've got vocabulary on the side here if I forget. Stored energy. Energy that has ability to cause change at a later time. At a later time. Well, that makes sense because the battery doesn't just run, I guess, because you have to turn it on first. So I guess that's the later time it's talking about. Oh, here's the picture. This is just like my kids pointing it at me. What happens when one side of a stretched rubber band is released? You know what that happens. Snap! Ouch! All right, so this next section says the stored energy of position. All right, so that's the heading here. I don't know what they mean by stored energy of position. I'll keep reading. Batteries and stretchy materials can store energy because of the materials of which they are made. Any object also can have stored energy because of its position. Okay, well, this is the key idea here in this last sentence, but I don't know how that has energy. Okay, well, since that's the title, and obviously I'm going to have to keep reading to find out. Imagine that you can pick up an apple and hold it above your head. Like a stretched rubber band, the apple has the ability to change position. If you release the apple, it will fall. Well, yeah, because you're not holding it up. An apple hangs from a tree branch, or when you hold the apple above the ground, it has stored energy because of its position. The same is true as if you hold up a ball or a book or a bucket. Each object has stored energy because it has the ability to cause a change once it starts moving. Okay, I get why the apple falls when you let go or when it's from the tree, but I thought that was like because we had gravity that pulls it down. Like Earth has gravity, right? So I don't quite understand yet about the stored energy of the position. I'll have to think about it as I continue to read. This apple has stored energy because of its position. Oh yeah, she was holding up the apple from the other page. I'm gonna have to think about this. So, energy can move and change. Okay, well, that kind of makes sense to me. But still thinking about that apple. Well, let's keep reading. Look at the napping cat in the picture. Not very energetic, is he? But there is energy in the scene that you might not notice at first. So let me look at this picture. Well, it is sleeping, so it doesn't seem like it's moving. So there's no energy of motion, because, or at least not by the cat that I can tell. Oh, but here's the caption. It says, light and heat are forms of energy that allow this cat to take a cozy nap. Okay. I guess. Well, yeah, light. So yeah, there's light shining on this cat. And the light has heat too, kind of like a light bulb, right? Because that might be a light bulb or it might be the sun, but the sun is definitely hot too. So but when I reread my heading, it says energy can move and change. This page doesn't seem to be about energy moving and changing. Well, I guess if the cat wakes up, then he'll have energy of motion, but I don't see anything changing yet. Well, maybe that's like in the next section. I don't know. Let me keep reading. The cat sleeps in a patch of sunlight. Light from the sun travels through space and transfers energy all the way to Earth. The sunlight pours through the screen door into the room where the cat is sleeping. Okay, so it was sunlight. The light enters the room, and when it hits an object, the energy of light is changed to the energy of heat. I guess that makes sense, because like when it's cold, like in the shade, well, maybe it's not really cold in the shade, but definitely when you go out in the sun, then it's hotter, right? So I guess that's why it's saying there's energy changing from the light to heat. Because under the tree or in the shade, the sunlight's not hitting it, so then you're not getting more heat from the sun. So the cat isn't moving, but energy that has moved across millions of miles is now in the room and warming the cat. In later lessons, you will learn more about how energy can move from one place to another and change from one form to another. Well, I guess that answers my question about how that works, because it won't tell me until later in the book. So I'll have to make sure to read very carefully next time we get to that part. Yeah, I'm still kind of thinking about, the energy and the position from the other page that we were reading, where the apple has energy. when you put it up here, or it's stored energy and then it falls. So I think it's saying when it's up high, then it could fall, right? And that's where the energy is. But if it's just on the ground, then maybe it doesn't have energy. So I think that means like the pictures I have in my house that are hanging on a wall, they have potential, some energy stored in them, right? Because they're just hanging from like a nail, and it could probably fall down like gravity, like like the apples do. Or that book over there that's kind of teetering on the edge. I should probably move that before it really falls and scares my poor dog. So while you're thinking about that, let's head back to Mr. Kane's lab to see what else he has for us today. I will see you all next time.
Thank you, Ms. Wynn, for sharing the reading with us and giving us some time to think about energy and changes. I want to talk for a second about those changes that we mentioned before. And so I'm going to spend a little time thinking like a scientist does. And one of the things that scientists will do is they'll try to group things and look for patterns in things. So these are those items that we had identified on our example sheet on activity page 1.1. So let's think about different ways that we could maybe group these. So I'll give you an example. I noticed that some of these things heat up a little bit when I use them. So I can put them into a group. So a glue gun gets real hot when I use it. A light bulb can get pretty hot. Now, grass doesn't really get hot at all. Maybe the sun heats it, but it doesn't heat up on its own. A fan, I guess it warms up a little bit. The electric motor might heat up. A hand drill, that doesn't heat up too much. It would get a little bit hot. The drill bit definitely would. And a hole punch, maybe if I did it a lot, it would heat up. But overall, that doesn't get too hot.